All right, guys, Mr. Jenkins back here with the rest of your 4-8 notes. So just to kind of recap on yesterday, we got up to this example where we were learning how to kind of rationalize the denominator. You guys may have questions about 12 and 13, and we can talk about those, the next time you're in class. But the big ones are like 14 through 17 on these examples. So that's why I kind of picked those. But 12 and 13 are worked out on the notes, and you guys are more than welcome to ask about those too. Today we're going to focus on the last couple of types of examples where we solve equations, and then we talk a little bit more about these powers of I. All right, so let's go ahead and just kind of look at these. So 1, 2, and 3 are all kind of simpler types of equations because there is no bx term. So remember on these, no bx term equals easy. Okay. So it's easy because all we really need to do is isolate x. So on number 1, for instance, I would move over the plus 9, rewrite this as x squared equals -9. Take the square root of both sides. We get x equals plus or minus. Don't forget that plus or minus because 2 solutions. The square root of -9. And then, of course, if we type in -9, our square root of -9, our calculator is going to say error. So here's where, if you haven't watched the day 1 video, you're going to have to do that first. But this simplifies to x equals plus or minus. We think the square root of 9 is 3. And then, so we end up with 3 times the square root of -1. So I square roots of, I square roots of 9, which would just be 3i. All right, then maybe, I don't know, I'll probably skip 2 and 3 because those are pretty basic. So go ahead and solve number 3 for me and tell me what your solutions are there. Number 4 and 5, we'll take a look at those. So as you can see, we're going to solve using the quadratic formula here. Your first thought should probably be, how do I factor this? So we're thinking, if this were on a test, we'd be thinking, what's going to multiply to equal 6, because 3 times 2 is 6, but add to -1. And so our initial thought would be probably 3 and 2. We can probably make that work. But, what's going to multiply to give me +6 would be +3 and +2, which add to 5, or -3 and -2, which add to -5. So you can't make this work, can't factor it. So in that case, quadratic formula would make sense. So here we go. A is 3. B is -1, and C is 2. All right, so then we sub in, and we see it, -b plus or minus square root, all that good stuff. So let's go ahead and sub in. So x equals -b. So instead of writing -1, I'm just going to write 1. Okay, so -1 is 1. So let's see if this can catch up real quick. So x equals 1 plus or minus. Sorry about the sloppiness there. Plus or minus long square root sign. B squared. So -1 squared. You might just type 1 squared there so you don't mess it up. Minus 4 times 3 times 2. All of that is over 2 times a, so 2 times 3. So now let's start to simplify. So this ends up being 1 minus, it looks like 24, so negative 23. So we have 1 plus or minus the square root of negative 23 over 6. And then we kind of simplify as much as we can. If you ever have a negative under a radical, you are not simplified, right? You have to, at the very least, write that as an imaginary number. And then you think about the square root of 23. 23 is prime, so we can't really break that down. So our next step would just be to say that's 1 plus or minus I square roots of 23 over 6. Okay. If it's ever a complex number, their Math Excel is going to want you to split that up. Okay, because that's how we do a complex number. A real number part plus or minus, or just plus or minus an imaginary number part. So our cleaned up answer would say x equals 1 over 6 plus or minus. Let this get caught up real quick. The square root of 23 over 6i. All right, let me go ahead and do number 5 real quick, so just so you can see another one, and I'll go a little bit quicker on that one. All right, so I'm going to go ahead and tell you we can't factor it, so let's go ahead and use quadratic formula. X equals negative negative 4, so that'd be positive 4 plus or minus the square root. Give me just a second here. Let our screen get caught up. So b squared. So I'm just going to write 4 squared. It's really negative 4 squared, but that's going to give me the same thing. It's easier to type that way. Minus 4 times 1 times 5 all over 2 times 1. So simplify what's under the radical. That'd be 16 minus 20, so negative 4. And we have 4 plus or minus the square root of negative 4 over 2. This one's going to be a little bit easier to simplify because the square root of 4 is 2. But remember, it's negative 4, so 2i. So that's 4 plus or minus 2i over 2. And then we just clean it up for our final answer. So x equals 4 over 2 is 2. Plus or minus, and then 2i over 2, we would just write that as 1i. So 2 plus or minus I. All right, so, imaginary solutions are not as nice because, it's hard to tell by looking at a graph. We can get more into that discussion tomorrow, but it's also hard to kind of sub an answer like that back in. So we can look at some things like that tomorrow if you guys would like to. All right, now looking at your patterns of I. Once you get this, it's really simple, I think. But that being said, sometimes it's kind of tough to get. So remember, I is equal to, the square root of 1, right? So it's a good reminder. Sorry, square root of negative 1. All right, so powers of I. Or patterns of I, sorry. All right, so I, to the first power is what that means, is just equal to I, right? There's no way to really simplify that. That's simple enough. I squared, remember that means the square root of 1 squared, right? So that would be equal to the square root, that would be equal to negative 1. The square root of negative 1 squared is negative 1. Right? And then I to the 3 then. So think about that. That would be equal to, another way to think about that would be, you could break that down as I times I squared, right? Or I times negative 1, which would be equal to negative I, negative 1i. And then the last one, I to the 4, kind of equal to I squared squared. I squared times I squared, which is negative 1 times negative 1. Should be positive 1. All right, so it seems maybe a little bit confusing so far. So let's see what happens as we keep going. All right, so what happens when we get to I to the fifth? Well, we already have an I to the fourth. So let's think of that in terms of I to the 4 times I to the 1. So that'd be equal to 1 times I, which should just be I. Right? I to the 6. Well, that'd be equal to I to the 5th times I. Right? So what's I to the 5th? That would be equal to, I. We just talked about that. And then times another I. So that'd be equal to I squared, right? I times I is equal to I squared, which is equal to -1. So you might be able to tell what's happening now, right? You could probably guess what I to the 7 is going to be, right? That'd be equal to I to the 6 times I, right? Or -1 times I, which would be -I, which is equal to the same thing as above it, right? So now we see the pattern. So go ahead and guess what I to the 8 is going to be equal to. So hopefully you guess 1 because, and here's why that's true. So it's equal to I to the 7 times I, right? So -I times I would be equal to, -I. Think about how to say this. Yeah, so -I times I would be, yeah, so sorry, that'd be equal to -I squared, right? Which would be equal to 1. All right, so anyways, the big thing to understand there is that it does start to repeat, right? There's 4 possibilities when you have any power of I, right? So you got to think in terms of 4s, right? So you kind of have to memorize this first row. It goes I, -1, -I, +1. Some generalizations in this first row are that if the power of I is odd, 1 or 3, it's either going to be I or -I. If the power of I is even, 2 or 4, it's going to be -1 or +1, right? So at worst, if you make those generalizations, you got a 50-50 shot, okay? So beyond that, though, I think about how this is in terms of 4. I'll try to show you what I mean. All right, so 25 out of the 25. This will be like what you have to do on your homework or your test. Simplify something like this. All right, so I to the 25 is either going to be I or -I. I know that right off the bat, right? And here's the easiest way for me to explain what it is for you, right? So I think about 4 into 25, right? Because I'm doing powers, it resets every 4th power. So 4 goes into 25, doesn't matter how many times, it does go in 6. What we care about is the remainder, okay? So this is like, what we care about is the remainder. So I know if this is 25 divided by 4 is 6, remainder 1, right? So that tells me then that this is really equal to the same thing as I to the 1st power. Okay, so that would be equal to just I. Okay, maybe I know that definition or that explanation doesn't make sense to everybody. So here's another way you could think of it, right? You could rewrite this as I to the 24th times I, right? So I to the 24th, that's the closest multiple of 4, would be equal to the same thing as I to the 4, right? That's 1, all right? So you have just 1 times I would be equal to I, right? So I don't know. Kids have trouble with this. I don't think I'm real great at explaining it. But I always think about that remainder, and then I match it up with is it a 1, 2, 3, or 4? All right. Anyways, let's look at 2 and 3. Number 2. So I am concerned with this 31 first and foremost, right? So how many 4s? Let's do 4 into 31. So 4 goes into 31. It doesn't really matter 7 times. What matters is that you have 3 left over, right? So this is the important thing. So I to the 31 is equivalent to I to the 3. Okay, and then I can just go match it up. Oh yeah, I to the 3 is negative I. So this then is equal to 3 times negative I, which is equal to negative 3I. All right, and looking at our last example, I'm looking at my notes right now, and it says that this simplifies to negative I. It should be negative 3I, so I'll have to correct that. All right, so then number 3, thinking about 14. So what's your remainder if we divide 14 by 4? Your remainder would be 2. So this power of I is equal to whatever I squared is. That's negative 1. So this is equal to negative 4 times negative 1, which is equal to positive 4. All right, so that is kind of how those patterns of I work. You guys will probably have questions about that, but you know, that's what I'm here for. Ask them if you got them. And this video will be where you can skip around, so hopefully it helps. Hopefully you guys have questions that I can help you with. Thanks, and have a good one.